we are about to start. Let's just give ourselves a few more seconds to find a nice spot to sit, to seal all the doors and whatnot. So maybe I start with a bad joke I've learned yesterday. So a recruiter asks a developer, if you explain me what deadlock is, I will hire you. And the developer says, if you hire me, I'll explain you what the deadlock is. Yeah, okay. Hopefully we'll be talking today about less nerdy stuff, which is removing complexity from integration tests using test containers. Hello, Confitura. Nice to be here. Do you enjoying the conference? How was the lunch? Was it good? Okay, it was good. Right. And how was the day so far? Was it good? Okay. And how's the party gonna be tonight? Will it be good? I like, why no enthusiasm when it comes to party? Come on. It's Saturday, right? All right. Anyway, what we're going to do is we are going to write a simple, small Spring app, right, with the tests. Actually. Or, yeah, we'll do some intro and whatnot. And this is like what happens many, many times, right? So it's like we are going to write a Spring app, right? And also the tests, and like some people are disappointed and some are not, because many, many times when people look for a thing to sacrifice first, unfortunately, it's the tests, right? And then I'm on a private mission of changing that. So apparently, Retool did a little survey, the Retool for like building like applications from the blocks and whatnot, and they asked people like if there was this single thing that you could spend less time on, what would that be? And unfortunately, or surprisingly to me as well, individual contributors, like almost 1/3 of them said that it's the testing phase, right? Like writing tests, performing manual tests, or kind of testing. Like testing is the thing they wouldn't want to do. Meaning, I guess there's something not so quite okay when it comes to tests, so this is the thing they want to get rid of, right? And unfortunately, seniors and managing engineers and like team leaders and whatnot also said, I mean, slightly less of them, but still they think somehow that this is like the thing that maybe would be nice to get rid of. So it seems that testing like isn't pleasant, or it's like hard or boring or whatnot. So I guess we should change that. My name is Piotr Przybył. I work as a software gardener and software engineer in a company called Atomic Jar. This is how you can reach me after this presentation if you need to. So this is my Twitter and this is my email. Atomic Jar, an explanation, is a company like we're doing test containers and beyond, basically, right? Okay, so test containers. What it is? Does anyone know what test containers is? Okay, so I guess the other half doesn't know, and just they are intrigued about like what you guys intrigued about, like integration tests or test containers, or who wrote at least one test case using test containers? Okay, like a vast minority, I'd say. Okay, so we'll do some intro to that today. No worries. Okay, so the testcontainers.org is the page that you should go to when you seek for knowledge, for like manuals and whatnot. Okay, and it comes to that testing pyramid, right? I guess you know this testing pyramid, and as far as I can tell, the testing pyramid has been around for quite a long time. So due to whatever reason, people say that the unit tests are the thing that you should be like doing the most. Then there's the integration test, and there's the E2E tests, right? It's just more or less, do you know when this pyramid was shaped this way? Yeah, exactly. We like maybe we should trace it, or we could trace it back. But it was in the times when the computers were big, right? When the computers were much bigger than the thing that you can put in your pocket or in your wrist, right? Computers were big. They had buttons, right? Maybe Facebook wasn't a thing yet, and so on. So like, I'm not trying to discourage you from the concept of having like, I don't know, like how many tests of each flavor you should have. It's just maybe like doing the same thing or following the same paradigm for over and over for decades isn't quite what we should be doing, because things are changing, our systems are changing, and so on, right? So these days, I mean, who's doing microservices? Yeah, almost everyone in the room, exactly, right? So the pyramid comes from the pre-microservice era, basically. So maybe today we should do it like a different way. Maybe like the integration test should be like the bread and butter, right? And I'm not saying it this because I try to encourage you to like do only integration tests, right? All kinds of tests matter, right? It's just today in your like if you're unit testing, like what's the unit? Okay, is it really the single class or a single method within this class, or is it like a pack of microservices bundled together? Right? Because this is what your users see eventually, or what they use when they, I don't know, press a button in your application, right? So I'm not trying, like, maybe even like unit tests and integration tests aren't like totally different these days. Maybe they are more or less about the same. It's just our units now require more integration, and therefore we need more integration tests, basically. So maybe this should be like this, octagon or hexagon shape, right? Or maybe this should be like this trophy shape, or I don't know. Like I don't know. I don't care about the shape. All I know is that we should also have such kind of tests, right? It's because of this. When I tell you the glass is half full, right? Did you hear the word empty? No, of course you didn't. Like, but this is what I implicitly said. If the glass is half full, it means it's also half empty, because what else would that be, right? So when I hear people saying that, oh, we are just doing like, this unit test with mocks and mocking and stubbing, and we're perfectly fine, and it's totally okay, right? So they say that, and what I hear is this. Okay, your mocks need to be so sophisticated that when you mock your database, for example, then when there is a new release of such a database, and when you're about to bump your dependency, then it means that you have to go carefully through the changelog, update your mocks, right? And even you have to like reflect in your mocks like the undocumented behavior you're relying on. Or the other thing I hear is like, I prefer testing in production. Right, when it comes to testing integrity of my things, right? Unfortunately, like, so this is what it means. And I also, again, I'm not trying to tell you that you shouldn't be using like unit tests or mocks in your tests and whatnot. They are very important and the primary thing or whatnot. Like, it's just they are not the only thing or alone. They are basically not enough, right? That's it. So when somebody tells you mocking and unit testing is just everything I need, think about the empty half of the glass, right? And the production. So test containers does this stuff because we are on the shoulders of the giants, basically. So everything you get from test containers, or like all the goodies and the promises and benefits and whatnot, they are coming basically from the fact that test containers relies on Docker, right? So to use test containers, you need to have Docker, right? Basically, access to a working Docker environment, basically. Why is this? This is how it, like some say, this is how Docker was born, right? So it works on my machine. Okay, so let's ship your machine, right? So this is one of the benefits of Docker. Like, you don't have to set up like somebody's software on your machine, like we used to do like 10 years ago or something before the Docker era, or even like we don't have to bother about virtual machines, right? We just pull the images, start the containers, and that's it. I mean, they've taken care of like initialization, like the structural file system and everything else, right? On the other hand, it's also nice for us, right? Because installing the applications, we can run them in Docker. And they are therefore quite easy, for example, to get rid of, or to when we have to dispose them, like we no longer use them, or we need to upgrade, or whatever, right? They are isolated, and so on. So it's like win-win for both the vendors, or also for the like users of a given piece of software, right? And that's why we like to run stuff in Docker. And okay, who has no experience with Docker? Don't be shy. Okay, many people. All right, so we're going to stick to this slide. So how does it work? There's a concept called Docker repository, okay? So there's like this default repository, and there are this, like you could also have like your own company-based repository, basically. And you pull so-called images, right? And the images are like onions and like cakes and like ogres. They have layers basically, and this is like the benefit of an image, right? Because you don't have to it's not like one huge tarball, but they kind of like rely on the same layers. So chances are when you are like pulling one image and then another image that they share, like, I don't know, these layers underneath to some degree, therefore you don't have to worry about this, right? And then so this is like the image pulling stuff, right? You go Docker pull image and ideally with a tag, right? Or even SHA to ensure that this thing is not going to change, right? And then there is the Docker run. This is how you basically run this stuff, okay? So this is the name tag that was pulled before, and we just map the port. So the port from within the container is outside visible under different number, right? Something like this. And what does it give us? It gives us process isolation, right? So the thing from the container, I mean, it's not that easy to break through and mess something on host machine. Like, it gives you isolation, right? You can tune independently the file system, the network. You can apply CPU and memory limits, right? So it's like, you know, all the goodies of isolation and safety and keeping things under control. Basically. And after you don't need it, you just stop the container and you remove the image, right? Should that be the case, basically. And you can also build your own images, and again, they're going to have layers, and you can run them as containers and whatnot. So this is what Docker is more or less about, like 101 in 2 minutes. So Testcontainers Java was created 7 years ago. It's a library. For Java, we support Java 8 and beyond, and it was created 7 years ago. And some say it's like, oh, but it's like, okay, Java is 27 and you're just 7, so you're not that old, not that reliable, okay? Docker, mind you, was created 8 years ago, right? So soon after the Docker became a thing, people realized that it can be used for like great stuff like integration testing, basically. And these are like the stats, unfortunately, they aren't up to date. I mean, we have now more like forks and stars and whatnot. And test containers under the hood relies on the Docker Java API, which is like Java library if you want to interact with Docker directly. And test containers integrates with frameworks like Spring, like JUnit. There's some Spock integration and so on. So it's not that you have to do everything on your own manually, okay? And system checks. Before you start using test containers, what you have to do, you have to ensure that your Docker is at least 1.6. This is one of the crucial things. And that the Docker environment can have more than 2 gigabytes of free disk space. The files should be mountable. And if the Docker container exposes a port, we can reach this port, basically, right? So there's like no local file system, firewall or something like this, okay? And one of the things I love about test containers is just, this is like a snapshot of things running during your test, right? This is what happens. And this is what makes it different, for example, from the the approach that we used to do before. So we had to, for example, install these databases on our machine. We had to start these databases. We had to put all the data in. Then the tests were running. Then there was the issue like with cleaning stuff after each test run. And then after the whole suite finished, we had to clean the data, the data inside the database. Okay. And there was also another issue that we couldn't run two suites in parallel, like reaching for the same data, because this was problematic. Okay. This is basically no-brainer and no issue for test containers. And after the whole test is done, it basically cleans after itself. Okay, there are no more containers. I mean, if you started some containers on your own, they will of course keep operating, right? I'm talking about these which were started by test containers. Okay, so test containers cleans after itself, basically. So you don't have to worry like about data races and initialization of the data and stuff like that. Because our goal, or the goal of the test containers, is to make not only address certain problems, okay, but also go like an extra mile. So, for example, there are these port conflicts, right? Therefore, like, for example, if you can't normally test two things if they also always bind to the same port, okay, or like two test suites run concurrently, or different products or libraries, whatever you call it. And what we do to address that is that the ports are randomized. So every time the thing from a test container is exposed under a different port, it's about data-driven test instead of hard-coded scenarios, okay? And the answer to slow test is basically to run them in parallel, okay? So this means like basically that the overall throughput is therefore increased when it comes to testing your stuff, right? And test containers is not just about Java. It's not just one thing. So if you happen to work like in Rust, in Scala, in Go, in Python, there are also libraries dedicated to be like friendly in these technology stacks or ecosystems, whatever you call them. And one of the things I like and but also hate when it comes to making presentations like this about test containers is just I hectically have to update the slides, because since yesterday we also have test containers for .NET, right? Like an official library. So this is what happened like just a bit more than 24 hours ago. So as you can see, the thing is pretty much alive and evolves at speed of light. And I'm really, really happy that I see so many of you. And there's also this thing, right? So these are the trending libraries, trending Java libraries on GitHub. And I made this snapshot also before this presentation. So as you can see, Test Containers Java is number 5 today. And so it was yesterday, okay? So if you're looking how you could, if you were like a backend developer, right, in Kotlin, in Scala, in Java, or basically like in these ecosystems and show you, then test containers is the thing for you, because it goes up, right? It's not just me. It's basically the community, what the community says, right? This is like coming from the actual people using it. And if you need to, like, I don't know, get yourself some space in your corporate or something like this, no worries. Apparently, according to ThoughtWorks, the time for like considering or scratching your head, shall we go for test containers or not, is over, right? Test containers is now marked or put in the adopt zone, meaning no longer worry about it, no longer consider it, just adopt test containers Java, basically. I mean, of course, you can like disagree with ThoughtWorks, but in case you like do agree with them, this is what they say, right? So go for it. All right. So I guess I could go with slides and like talking to you what it's like and whatnot, but I guess like the actual truth is in the code, right? So it is like a code is much more difficult to fool. So the application for today is going to be slightly overcomplicated, slightly over-engineered, but it's not to be used like in real-world scenarios, but to be like a good field or playground for today, right? For like how to get quickly used to test containers. It's quite simple. It's about conference, okay? So we have a thing or a concept called rating. Right, and we are going to rate a talk, and we're going to give some like ratings, like the value, right? How much do we value the talk? What's the rating of a talk according to us? And yeah, this is like somewhat overcomplicated, as I said. So we have the ratings controller talking to talks repository, which is using a database, right? And also using ratings repository, which is going to cooperate with Redis. Because why not? Because we wanted to have it in our demo and in our resumes, okay? And also, ratings controller can talk directly to ratings listener, but they have to use Kafka, right? Because we expect, like, I don't know, crazy load of the ratings and whatnot. Therefore, there's also Kafka in the landscape, and this is more or less the thing that we're going to work on today. Okay, show me again. What is it? Okay, yeah, double slide. Sorry. So let's go to the IDE. By the way, should you have any questions, no worries. Just wave your hand or something. I guess we have some microphones so we can ask you a question and whatnot. So this presentation is not about me talking, but about you getting the knowledge how it basically works. So as you can see, we have a Spring application because Spring is like at least quite popular, I'd say, right? If not more. So this is the ratings controller. As you can see, you're just using the repositories, and you see the Kafka template. And we have the rating, so the thing that we're going to persist, and we have the ratings repository, right? And it's going to use Redis, as you can see, and talks repository using JDBC template. So basically, it seems I didn't lie. The whole thing compiles, the whole thing runs. Okay, so what I am going to do now is we're going to this is the schema that we're going to have for our test, right? At least for now. So the ID, the title, and we are going to run our first test. We're going to see if the context loads, right? So we have a test, and we extend this just for sake of simplicity of the demo. We extend this abstract integration test, which is, as you can see, Spring Boot test. So I hope you folks are writing Spring Boot test, and we're going to spawn it under random port because, for example, we want to have this test run in parallel, right? So we can't hook to a fixed port in CI or whatever. Okay, and this is it. So let's see if the test runs, if the context loads. Come on, apparently it does, apparently it loads, so it seems that all the things were wired together correctly, right? Okay, so we can finish, we can shift it to done in our Kanban board, and we can have some time to play Counter-Strike, right? Unless we didn't go through the PR and someone was so picky that they said, okay, listen, very nice, but maybe you should feed your test with some data. Okay, let's toss some data. Let's start using some real integration, right? Let's just not trust that the thing is loading, but let's basically put some data in. Okay, so let's rerun the test, and what will happen? Okay, it seems it didn't work. I have some umbrellas, I have some mugs, I have some jellies. I'm looking for an answer. Why it didn't work? Ideas. Don't be shy. Come on. It's Saturday. It's fun time. Right.
So maybe the database was not ready yet to accept any data. Or maybe there isn't any database yet.
Unfortunately wrong. There is a database, so I will show you. I will show you the exception, right? And the exception is pretty much in here. So we have and we have JDBC SQL exception, and what it says is that SQL statement, blah, blah, syntax error in SQL statement, right? So, but it seems like okay, even IntelliJ doesn't complain. So what on earth is happening? The thing is, our application works with PostgreSQL, not just any database, right? It's not portable, it's not like ORM or whatever, and therefore H2 complains because it doesn't understand the syntax, right? It's not its syntax, right? This on conflict comes from PostgreSQL. So it turns out that we need to test it against the real thing, like the actual PostgreSQL. So how do you do that using test containers? It's not that difficult, I hope. So we go to build Gradle, for example, and we add this dependency for test implementation or test containers PostgreSQL, which is one of the modules of test containers, right? Or if you have to happen to use POM, you just go to your POM and you do the same basically here, right? So we add the dependency, that's one thing. And the other thing that we have to do is, let's toss some properties here. One of the ways, we can solve that in multiple ways, but the JDBC, the concept of the JDBC, how is it called, URL or something? Rings a bell? Okay, right, so we're gonna say Spring data source URL is, and that should be JDBC, then it should be test containers because we integrate with it, and with Spring, I mean, and then it should be PostgreSQL, and then let's give the exact name, like the version of the tag. So let's run it on 14 Alpine, and now the database should be Confitura. I did that like, by heart. It might blow. Let's see. I mean, this is the purpose of testing, right? Let's see if it works. Because I maybe made a typo or something like this. I can never be sure. Yeah, I did something wrong. So what should it be there exactly? Yeah, let's just copy this. See, it's my personal Stack Overflow, so I can do that. Like copy and paste stuff from there. Let's rerun stuff again. Oh, see, so the container, it said container started, right? So what actually happened here, we just added this, properties to our Spring Boot test, and now the integration kicks in, pulls the image from Docker Hub, starts the container for you, right? And it feeds it with data and everything. So this is what it says. See, it's like started the container and everything, and our test passed basically, right? So now we have when we have the data, and let's try to see if we actually have the data in there. If the data is really there, let's run another test. Or to run another test, we need to have this talks repository, right, in our test, because else it doesn't work, it won't work. So let's auto-wire this talks repository, and let's see if the data is there, and this is the data that should come from this SQL file. So let's run the thing. And will it work? Won't it work? Okay, it worked. Okay. Very nice, very nice. It worked, as you can see. So actually, as you can see, we verified that the data has been there in a real database in actual PostgreSQL in version 14, right? We can rerun. No, it's yeah, it's a test. It's running. Oh, sorry. Yeah. Sorry. You're absolutely right. Of course. Good point. Umbrella, mag, jellies, pick whatever you want. Just comment. Okay. Pick and get whatever you want. Okay. Yeah. Still, the data is still there. All right. So let's actually run everything to make extra sure. But good catch. Yeah. Very good catch. Now we should have 2 tests running. Yeah, so they both run. Okay, cool, very nice. Let's proceed with our testing. Okay, let's use so-called actuator. Who's using actuator or checking the actuator for Spring? Yeah, exactly. So let's see if, according to our actuator, the whole thing is healthy, right? So this should be, and we're going to use the amazing rest assured library. So this should be given, and the request specification, yeah, because we want to maybe use it somewhere else, is going to be here. And we're also going to have this local server port injected by Spring, and we're going to set this basically in here. So just import it from Spring Framework. Yeah. So basically, this is like the request specification from rest assured we're going to use, and we're going to say that for every request, we want to hit this local server port because it changes every time we run it, because it says random here, right? And we're going to hit it, and we're going to see if the whole thing is healthy or not. So yeah, I should be running both tests now. Come on, come on, come on. And it's not healthy. How come, right? It's still not the Counter-Strike time. Any ideas? Who can shout out why it's not healthy? It's not. Sorry? Not connected to Kafka. I guess it's very, very close. Okay, get some jellies in my throat because it's, oh, sorry. It's almost there. Actually, it's complaining that what's used by this repository, okay? See, Redis, it wasn't Kafka, it was Redis, but it's like, no worries, it's basically, you don't have this diagram, right? Or we didn't examine the code in like great details. Anyway, this is it, the Redis. Now Redis is gone. So how do we add Redis? So to add Redis, we can go like this. And this is like the super generic way of doing or adding any basically thing that you need. And if there is an image, right? Or if you want to build your own image, then it can be started by Testcontainers, and this is how we do that. Let's go for a static final generic container, and let's call it Redis. Okay. Yeah, Redis equals new generic container, and that container should be ready. Let's use autocompletion. See, and this is what happens in the EAP version of IntelliJ. When you try to use test containers, it just gives you the options, like the possible containers you can use, right? So we're going to use Redis in version 6 Alpine, I guess. Yeah, so we expect this autocompletion to be up there soon. Right, so this is it. This is Redis. Question is, will this task work now? Who can tell me? Will it work? Won't it work? Probably no. Why it won't work? Sorry, you have to be louder. No configuration. What do you mean as configuration? It might be even simpler than that. We declare that there's going to be this container use, right? It's just we didn't start it, basically, right? And we also didn't add the configuration to Spring. So how could Spring know that this is the Redis that we're going to use? Yeah, that's again the same thing. So what we can do here is we can do something like this. We can use this dynamic property source in our for our tests, right? So let's go like this. Right, quickly try to run it, and yeah, let's go just like this. Let's just start this here, redis.start. As you can see, you don't need anything sophisticated. It's just, we say here, get host and get first map port. Does anyone know if this is necessary, or can I just safely use get host here? Oh, sorry, localhost here. Localhost may work on your local machine, but once the thing goes to CI, it may not work because, for example, the containers may be spawned in a different machine, which is like not your machine, right? So let's try to run this thing now. So this is how you can see, like, we configured Spring or told Spring what's the Redis host and what's the Redis port. So we just get host and get first map port. And again, it didn't work. Why it didn't work? I'm doing this the hard way just to show you that there are like steps, but there's the purpose in this. It didn't work because we can't ask like for the property of the first map port because we don't map the port. Okay, so we have to expose a port from this container, right? So with exposed ports, and what's the post that Redis normally exposed? I don't remember either. No worries. So it's 6379. Okay, this is the port. Let's rerun it. Come on. And now it works. How nice, right? It's just the thing is, you see, we had to use this generic container, right? And then to make yet another test work, which is in this very case, this ratings controller test, right? This test won't work. And it guesses why this test is not going to work. Because it uses Kafka. And again, we have to add toss Kafka on top of it. So this is how we do that. And this is the beauty of test containers, that we have so-called modules, right? So I'm going to add the instead of using generic container, I'm just going to use Kafka container, right? So this is basically like, can you, just by heart, can you configure Kafka, expose all the needed ports, set up Zookeeper and whatnot? Can you do that without like manual or whatever? Okay, so with Redis, it's quite simple. It's just about exposing one port. And with Kafka, it's a bit more convoluted, I would say. It's not that it's rocket science, but it's not like one-liner, right? Therefore, we have this Kafka container. So when you have to add this dependency, runtime dependency to your tests, right? So they rely on Kafka, you just use Kafka container. And there are more containers like this. See, these are all the modules. So we have modules for the various databases, right? And should you test your Azure stuff, there's also this for Elasticsearch, for Kafka, local stack, if you deploy stuff on AWS and you want to like integrate test it before. There is a Toxic Proxy if you would like to test like if you're resilient towards, for example, increased latency and whatnot. So there's like a great number of modules, right? And just an example, because we're running out of time, how to do that here. What we're gonna do, let me just comment this thing out, like remove it and bring this thing out. Okay, so one more thing. Instead of like doing these properties here, we are going to use Postgre container explicitly. So my personal Stack Overflow comes here, right? So now we have all the 3 containers that we use for dependencies, right? So it's Redis, it's Kafka, it's PostgreSQL, and this is how we tell Spring where it exists for this given test suite run, basically, right? So we say that Kafka Bootstrap service comes from Bootstrap service from this Kafka container, right? Which is like operated by this Kafka module, and for PostgreSQL or pretty much any other JDBC or like database module, basically we can do it like this, right? So we told Spring, here's your Redis, here's your Kafka, and here's your data source, right? And let's try to run this demo application tests if it still runs. Come on. See, it started Kafka, right? It said like Kafka start, so the Postgres starting, Redis starting, and Kafka starting, and we like did it using the parallel stream. So all 3 of them are starting in parallel, basically. So we don't have to do that sequentially. So as you can see, I mean, there's also supported way that you go here, basically, and then on top of your test, you basically can add the annotation that tests containers, right? And inside, when you have these fields and you annotate them with container, they will be started and so on. Like, and if you make it like a static, then it will be started just once. And if you don't make it static, it will be started for every test you run, should that be the case or you need, right? So this is like the optimization what we did here, because unfortunately we don't have that much time. Right, so this is how it works, and as you can see, we like in a few minutes created an integration test, right? And you didn't have to install Kafka or Redis on PostgreSQL, right? We didn't go to their pages; they didn't have to be downloaded. The whole thing is just started for the test, right? And when the test stops, it's basically like removed from the memory. It runs no more. Right, and as you can see, you can easily run your custom data there. You can add like, I don't know, throwaway integration or test your migrations or whatever you have. Basically, no worries here. Okay, so let me go back to the slides. I mean, do you have any questions? Okay, question there. Question is question. What do you mean running on Kubernetes?
When you want to embed it in CI process and you want to run it using, for example, Tekton or Jenkins on Kubernetes, how you spin containers from the container? Then you would have to have privileged container.
That's one option, and another option comes just in a minute. But I'm really glad you asked this question. I mean, I don't know you, and maybe you know me, but I don't know you. So this wasn't set up. I like it. So basically, you have to provide a Docker runtime environment, right, to make this thing happen. basically. So there is like no any kind of magic. I mean, the Docker has to be there.
Okay.
But it runs. I mean, it runs without any issue in pretty much every CI I'm aware of.
So you mean I'm using privileged containers, and in container I run another container, right?
I mean, if you want to set up your Docker this way, yeah. I mean, it's up to you then to ensure
it's some kind of vulnerability.
We'll get to there. We'll get there. Okay. So,
okay.
Any more questions? Question over there in the back. Question is, what about custom images, right? You can run any image, right? So I was using the images from Docker Hub, like the public images, but you can use custom images, and if you want, you can even like toss your, you know, the how is it called? The image descriptor or whatever, right? From Docker, and we can run like this. So it doesn't have to be like public, and I mean, I encourage you to do like this. But it's like you can run pretty much any other image or start pretty other image, okay? So there's more things when it comes to test containers. As you can see, the API is your friend because, as we know, developers hardly ever read manuals or documentation. So it's just the Fluent API. So you can like start it with like not only port but only a command, like an environment, and we can copy certain files to the container if that's what we need. We can execute a command in the container if that's what we need. Basically, just as you would normally use Docker from your machine, right? It's nicely wrapped for you in the API and cleaned after each and every test, right? And there are custom startups and custom waiting strategies we support, as I guess just asked. So creating images on the fly is also possible if that's what you need, or using like custom images or whatever. And by definition, there is no YAML, so no yelling at my laptop. Unless you like desperately need to, then you can also do that, but it's not like required in vast majority of scenarios, I would say. Because our philosophy is like this. When you have a problem to solve, okay, it's not big deal if you replace a hard problem or a difficult problem with a hard solution, right? It's like, where's the win, okay? And also, there shouldn't be like much time needed to replace an easy problem with an easy solution, because it's just basically, I don't know, like the art of bike shedding or whatever. The thing is, as we believe, that the hard problem should and can be replaced with an easy solution, right? So instead of setting up all these things needed to perform your integration tests, you can just toss test containers on your class path, have a working Docker environment, and that's it. Basically, that's basically it. Question is, what happens if you have no Docker, right? Because like the Kubernetes, or you like, who's using Windows? May I ask who's using Windows? Okay, like many people. So okay, who's using Mac? Also no native Docker, I guess, right? So I'm using Linux, so I can have like that easily. If you don't happen to have that, this is like we do at Atomic Jar, we go beyond, right? So this is like the list of strategies, what you can do when you have no or what available Docker environments, right? The article is on our webpage. So it's about like Docker Desktop, Docker Machine, Minikube, or Podman, right? Like what you can use, like basically if you have no Docker. So go like apt install Docker. And the thing, what we are doing right now, is the Testcontainers Cloud. As you can see, it's already used by certain companies, right? And if you also would like to use it, then you have to, or you should go to the testcontainers.cloud, right? Like register yourself and like wait for the access to be granted, because currently we are in a phase of private beta. Because I wanted to show you this. As you can see, the Docker is not working on my machine. So you may ask, what the heck has just happened? I mean, no Docker on the machine, and he was running like Docker containers, like we saw that in the logs. What's going on? And the answer is exactly Testcontainers Cloud, right? So it works very, very nice in Warsaw because we're basically sitting on a cloud node, right? So all the stuff, all the containers that we had were running in the cloud. So this might be, and this is like the solution we have for like Docker-less desktops or Docker-less CIs. So still, if you don't happen to have Docker working, or because you can't have it due to whatever, right? Then you can have Testcontainers Cloud, and as you can see, it will show you, like, it will connect to like edge computing, node, and all your stuff will be running there. So we don't have to work about privileges, for example, that DB2 requires also elevated containers, right? Like privileged containers. So that becomes like we solve that for you, basically, right? So see, no Docker on the machine yet. Test containers still work. What's next? If you got intrigued, please go to testcontainers.org. I didn't. How do I mute that? Okay. Testcontainers.org. There's also a link there to our Slack channel. Should you need more interactive help, we're also eager to help you. Okay. There's Testcontainers Java on GitHub. Like, you can clone it, you can fork it in case you need it, or if you'd like to just read the sources. And there's the code I have shown you comes from the Testcontainers workshop, our workshop we prepared for communities and so on. So I guess that would be it. Thank you very much for today, and enjoy happy integration testing. Thank you.